In this lecture, I'll discuss why self-inductance of a coil is said to be analogous to the mass of a body. I have shown three different states of a body. The mass of the body is M. In the first state, the body is at rest. Then finally also the body is at rest. In between, the body is moving with velocity v. Now the question is, will the body automatically start moving? Answer is no. The body requires some external physical quantity to be applied on it in order to start its motion, and that external physical quantity which has to be applied to make a body at rest moving is called external force. So you have to apply external force in order to make this body which is at rest moving. Then again, in order to make this moving body come to rest, you will have to apply external force. You will have to apply external force. So mass is that property. Mass is that property which opposes the changing state of motion of the body. In order to start motion in the body, you have to apply external force. Without external interference, the body will not start moving. Similarly, in here also the body is moving. In order to make it stop, you have to again apply interfere with the state of motion of the body by applying an external force. Okay. In between, that means if you consider this state when the body is moving, if you ignore the resistive forces, if the resistive forces are withdrawn, resistive force means frictional force or air resistance, if they are withdrawn, then the body will continue its motion, and to make the body continue with its velocity, you will not have to apply any external force. So one thing should be clear: in order to change velocity from v equal to 0 to v equal to v, you have to apply external force. In order to change velocity from v equal to v to v equal to 0, you will have to apply force. And in order to let the body continue with its velocity, you will not have to apply any force. So mass is therefore mass is opposing any attempt to change the state of motion. Means a change from v equal to 0 to v equal to v, mass will oppose, and in order to overcome that opposition, you have to apply force from external source. Again, a change from v equal to v to 0, you have to apply external force because mass is opposing that change. But in between, when a body is moving with velocity v, mass is not opposing, and that's why you will not be required to apply force, external force on the body. Okay, now come to self-inductance of a coil. I have shown a coil which looks like a solenoid in three different states. In the first state, no current is passing through the coil. Then I have shown that a current I is passing through the coil, and then I have shown that no current is passing through the coil. So there is a change in the state of electrical flow through the coil. There is a change in current. It has changed from I equal to 0 to I equal to I. This change will not automatically occur when we try to pass a current through the coil opposes, and in order to overcome that force of opposition, you have to apply external force, and that external force is supplied in form of EMF of a battery. So you have to apply external force in order to make current change from 0 to I. And again in order to change current from a value of I to a value of 0, again you have to apply EMF. In between, when the current is, that means when the current is flowing through the coil with unchanged value, no EMF is required. if we ignore the resistive forces, means resistance of the body, then current will automatically flow through the coil. So external force has to be applied in order to increase current from a value of 0 to I, and again external force has to be applied in order to decrease current from I to 0. Okay, now let us come to this. We know from Newton's second law that F external equal to m into dV by dt. Here we know similarly E equal to L into di by dt. Who will exert this F external? Some external entity. It may be a person who is pushing the block, or here who will apply this EMF? It may be, for this you have to apply a battery of EMF E. So E equal to L into di by dt. Here the property of the coil which opposes any attempt to change electrical flow through it is termed as self-inductance of the coil. So increase the current, self-inductance will resist. Decrease the current, self-inductance will resist. And allow the current without any change, self-inductance will not do anything. It will neither oppose nor it will favor. It will not do anything. Now compare these two expressions. F external equal to m into dV by dt and EMF equal to L into di by dt. So we find that these two, M and L, they are analogous. Okay. F external is external force, EMF is also external force. Rate of change of velocity is comparable to rate of change of current. Now, this external force, when this external force acts on the body, external force does work on the body, and it loads the body with energy. So external force by acting on the body loads the body with energy. Here also this external force, electrical force or electromotive force, it acts on the coil to load electrical energy in it. Okay, let us see how. W, work done by F external, work equal to F external into ds. We are considering a displacement of the body, ds. Work done by external force is integration F external into ds, and equal to m into dV by dt into ds, m into ds by dt into v, m into v into dv. So this is equal to half m v square. So external force by acting on the body does work on the body to load energy in the body, and that energy is in form of half m v square. Here also this EMF, it does work against the force of resistance exerted by the coil. How much work does it do? W equal to integration, suppose this point is A, this point is B, then we know the formula that work done to pass a current, pass dq amount of charge from point A to the point B is Va minus Vb into dq. See, this Va minus Vb is actually external force per unit charge, Va minus Vb into dq. So I will replace Va minus Vb by E is the EMF of the battery, and I am assuming that there are no resistive forces, equal to E A into di by dt into dq integration L dq by dt di integration L dq by dt is I di equal to half Li square. So this external force exerted by the external source of EMF does work against the force of opposition exerted by the self-inductance of the coil, and the work done by this force, by the external EMF, remains, or it gets stored in the body as energy, and the magnitude of this energy is half Li square. Again, you can compare this expression, this is called magnetic field energy, with the kinetic energy. This kinetic energy, this is magnetic field energy. So again, we should compare these two, and we find that mass and L, self-inductance, are analogous, and again velocity of a body is analogous to the current through a conductor. So the summary is, external force does work against the force of opposition exerted by the mass of a body, and the work done by the external force remains stored in the body as kinetic energy. In the case of a coil, the EMF of the battery does work against the force of resistance exerted by the self-inductance of the coil, and the work done by EMF gets stored in the inductor as magnetic field energy. Okay, here the external force has to overcome the force of resistance against change of velocity. Here the EMF has to overcome the force of resistance against change of current. Okay, so we have understood that mass is analogous to self-inductance. So stay with me. Every Sunday I will upload a lecture. In the next lecture, I will discuss why capacitance of a capacitor is analogous to the reciprocal of spring constant.